let me first review where we are. Um, you can see that on this coming Monday at midnight, you have activity 2 due, which is, let's look at that. That includes the lab activity 2, which is the going down and going up, and also there's there's some chapter 5 programs, but the chapter 5 programs included are those up through arrays. So you can see over here that they're only the programs from pointers, function, and arrays. You can see the specific functions, the specific programs that will be included by doing the p check to see, what's included here. But that means that strings, structs, and these exotic to-dos are for next week's the final C programming work. So that's one thing. And then the second thing that's due are the two projects, CAT and CP, and they're in chapter 6, the beginning here. We've already introduced these. There's a few questions here actually on CAT online, and maybe a couple here, but otherwise they're basically the P-check stuff that you have to do. Let's see. Well, last time we sort of went up to
Epey o
structs.
zaman. Bana epey uzun vertela.
David, you have a question? Or maybe you meant to be muted. I don't know. There. Okay. So maybe what we'll do today is I can spend time answering questions about this stuff. Like we could divide up into breakout rooms. I could answer questions about CAD and CP. Those are the main things. You probably have these issues. These programs aren't particularly, they're basically, you type them in, compile them, run them, and try to understand them. But CAD and CP, you have diagrams to draw, which aren't difficult. They're like the previous ones. And but then for CP, you have a table to fill out and turn it on Piazza. Okay. So any questions about this, what's due, or the mechanics of stuff? Okay, well, jump in if you do have something. Let's look at, just to finish the story that we started about structs. We can go ahead and finish that. Let's do it in a program. It's going to be easier in a program than in Pico C. So let's say that we define struct person. The struct, this is like a class definition. Notice unusually that it has a semicolon after it. And so we can let's give it a few variables. Int letter. Oh, let's call this though a char. And this would be a char star for name. Okay, so what's in the struct is not the name itself, but a pointer to the name. So this has a well-defined size, no matter what the size of the name is. So let's int main. Okay, so we want to declare a struct person object. Say Hector, and then what you have is you can say Hector.age equals, say, maybe over 2000, because this is, he's really old, from ancient Greek times, like the Hector in the Iliad or something. Okay, so then the letter we can give is H. Okay, and the name, we can try to, oh, and we have to do this as letter, not letter.letter, but Hector.letter and Hector.name equals. And let's see if this actually works. Printf percent age is an int, so we say use I. And then we can do %C for the character and %S for the string. And then we can put in here Hector.age, Hector.letter, Hector.name, and see if this is, and since this is you can't do this in the project thing, so we can do this in the C programming stuff. Okay, so let's call this struct example.c. Okay, so there it is, and let's check and see if we've made any errors. Okay, we haven't. So let's see if it actually works as expected. Okay, so it printed off 2000, which we expected from that. It printed the letter H and it printed the name Hector. So this is how you declare. This is a struct declaration. It's like a class definition. However, unlike a Java class, which has field variables and methods, a struct in C just has the analog of field variables, and in some sense there's no public and private, so these are public, so you can just refer to them directly. You don't have to have getters and setters or anything like that where you've made so that there's but this is sort of the primeval ancestor that came through C++ that then was modified to be the basis for classes and objects in C, in which here was the class definition, and here is where you actually allocate space. This looks like just what it does is it declares space for this much for the struct. So this is actually like in if this was a class person in Java, you'd have person Hector equals new person, and maybe have a constructor that would fill in these values. So we don't have a constructor. We just have to fill in the values manually, and then you access them with the dot operator, which was inherited by Java along the way. Okay, so any questions about this? Okay, well, there's something. Let's continue the story here with the you can have pointers to structs. Like here we have a struct but we can also have a struct person star, an alias, right? And then we can set hero to, since hero is a pointer to something of type struct person, so we have to give the address of the struct. Now, if we want to print off and have it look the same, but use the pointers rather, we want to use the pointer here, well, you can't, because this is a pointer, it turns out this is slightly different syntax. What you have to do is you have to make this little funny arrow symbol, which is a dash or a minus sign and an arrow, and do age. Okay. Because this sort of arrow sort of means you shoot through the pointer and get the so you don't have like a star, you know, you don't, it's, this is takes the place of the star for a pointer. So let's see if this works. And oh, I didn't put a semicolon here. When you get errors like this, like there's a whole bunch of errors, what you need to do is just fix one thing and then recompile, because oftentimes that thing didn't. Oh, yes, and you can see what I did. What I did here was I said, see, hero is the pointer, and it only gave me two errors. So the error was that I used the actual struct rather than the pointer here. Okay, so there, let's see if that works now. And you can see it's telling you that this is not, you know, not the right thing. Okay, now it works. Oh, there, let's see if it works. Okay, so it produces exactly the same result. So this is how you access the fields in a struct, either the struct directly or with pointers. Now, it's interesting if you want to have a function that messes with, for example, let's say we wanted to have a function that was going to not have a return type, but was going to set the name. Say, let's just do one thing at a time. Let's say um, well, let's not use camel case. Set name, and what we're going to do is we're going to do struct person, a person. So there's the header for the function. And what we wanted to do is, well, actually, we're going to give it char star name. What we want to do is we could just do it directly, but let's say just for this that we want to set this name into this field variable here. Maybe I should do a simpler, just do int age. Okay. Now, C is passed by value. So what that means is a copy. This is the struct here. When I pass like Hector in here, an entire copy of the struct, the value is passed in. So you get a duplicate copy of Hector inside this function. So let's see what we can do with this function. So this is a case where we're taking the values in, and we can do a person dot age equals age. So I'm just setting the parameter value to the field variable age in struct. So this is sort of like what you'd think of in Java as a setter, right? Because it would set the value of the struct. However, it's not in the you can't associate it, you can't put it in the struct definition. Let's see now if we've made any mistakes here. And oh, well, so what I want to do is I want to call the function. So we'll change the age here, and we'll call set age Hector 500. Okay, so that matches this. Let's see if this still compiles. It did, and let's see what happens here. And so we don't see the 500 here, right? Because this just set age in the struct, the copy of the struct, and then we forgot that. So if we went in here and we printed printf %i new line, this is age in function, a person dot age, just to see that this actually did something. See, age in function was 500, but we didn't change Hector out here. So we just, so this is shows that what you actually want to do is, let's have a second one. Let's call this bad because it doesn't really work there. And then what we'll do is we'll make another set age with a pointer to struct, so we can set age here, but instead of a struct, we'll make a, declare it to be a pointer. Get all the syntax right. Okay, so here is so here what I can do is, what I want to do is I want to get, see, a person, I want to set a person right arrow age equals age. And then return. So it looks the same way here, except you're using this little funny arrow thing. Let's see now if this works. Nope, made a mistake. Let's see. Oh, because up here, when I call set age, I'm calling it without a pointer. I need to put in the address of Hector here. Let's see if I got, oh, and also, yes, let's see if this works. Yes, it works. And let's, okay, now, so the Hector, this is printing it. See, both of these now work as advertised, that I've changed the age inside, by passing the pointer in, I was able to change the field variable, not in the copy of the struct that was put in here. All that's passed in here is a pointer to this, to the memory allocated here. This is where memory for struct allocated. Now you could, if you wanted to like initialize a struct and then return it, you could pass in, pass in the struct definition, or since this is like, if you declare something up here, it's global. So I could initialize this, like sort of make an analog of a constructor in which I just created a struct inside the function, but I have to use malloc to do it. And so I'm going to stop here. This is the basic syntax that we're going to use of structs and with pointers to structs, except for one thing, which is it's annoying to have to keep typing this thing here. So what I can do is I can do type def, and I want the known one, struct. Well, the thing to do is to give just say, let's see. Well, let's make sure that I'm doing this exactly the way. So you have a struct student, and then here is a struct a type, here's a type def. See, you can do type def, struct, and student. Okay, so let's come back here. And this is one way to do it, but I can also say, put the word type def in front of this, but then that is the struct from here to here is the definition of the struct. And then I don't put I just say there's a struct, and then I'm going to say this is of type person. Okay. Now, what all the way through here though, let me call this a different um, call this student, and then leave the so I don't mess up the rest of the program. So everything should work as before, but we can call this, let me see. Um, Great. Okay, it's just to make it okay. So now we have so we have this type def, and now down here we can say uh, student. Um, let's say para. So that declares another struct of type student, right? And so it's basically going to be the same way that you would do Hera dot grade equals, it's a letter, so give them an A. Okay, so this is how you use a type def to take a struct and give it a name. So in your code, you don't have to type struct person, you can just type student. So this sort of looks more like Java than the previous than the version with struct. But this is sort of all we really need with structs, because our first files that we're doing with cat and CP are just treating the file as a sequence of bytes with no structure. But later on, we're going to have files that are sequences of structs, and the structs will be like a record for a file or some login thing. So we'll have a struct, and we'll need to read in structs from a file. Well, you will still use read and write. We just need to read in this. We can have a buffer that will be this. We could have a buffer that would be of like type Hector or type whatever, and a buffer of type student or person, and then you read it in from a file. And we will see how to do that, because you read the size of the struct, number of bytes, and you give it a pointer and it writes them there. Okay, so this is all really about structs in here. So the next stuff, which we'll do next week, is there's some longer programs here with structs, but next week we'll start with the to-dos at the end of the chapter. But for here, what I'd like to do is, let's see.